G'day viewers. In this segment we'll talk about different kinds of media, wires and so forth. This is material at the bottom of the physical layer. Okay, so there are three kinds of media which are very common that we'll talk about. Wires, fiber optic cables, and also wireless is a kind of medium for propagating signals. The issue with all of these kinds of media is that they propagate signals. These signals carry bits of information. In this segment we're just going to talk about these basic types of media and get a little bit of a feel for them. Then we'll move on to understand how signals which carry the information are propagated across these media. So the first kind of media we have is just wires, twisted pair wire. That's your garden variety wire. It's quite common. This is the kind of wire which runs to your house for your telephone, assuming you still have a wired telephone. You will also probably seen it in enterprises. This cable shown here, the category 5 UTP, stands for unshielded twisted pair. That is a common Ethernet cable. You can see in here that there are 4 pairs of twisted pairs. The twisted pairs, each one is literally 2 wires twisted around. The signal is carried as a voltage differential across those wires, and they're twisted just to help reduce the interfering RF signal that's radiated. At least they reduce the radiation of that signal, and by reducing that we reduce the interference between adjacent pairs of wire. Another kind of wire here is shown in the picture in the middle. It's a coaxial cable. It's also fairly common. It used to be used to carry video signals, still is, for a cable to your home. These kind of wires generally have better performance than twisted pairs, meaning that they're able to carry faster amounts of data, higher data rates, longer distances because of their physical properties. You can see here it's built, instead of just twisting a couple of pairs of wire, it has a metal core in the middle, and that you can see here, and also an outer conductor around here, around the edge, instead of the 2 wires. And it's put together in a nice way. Both the twisted pair and the coaxial cable, you'll see them around. They're the most common kinds of wire, and they're designed for communications. There are many other kinds of wire we might use too. One interesting kind that you could just have a look at is household electrical power lines. These are starting to be used, for instance, to carry information around your home just by reusing the existing infrastructure. We can do that nowadays. You can read a little about it in the text if you'd like. A different kind of media is fiber or fiber optic cables. A picture shown here just of the operation of a fiber. The fiber is here in the pink. Now a fiber is really just a very long, thin, pure strand of glass. The way it operates is when you shine light in from a light source, that could just be a laser or an LED, a light operating diode. The fiber is so thin that the light bounces around. It doesn't come out of the fiber, it bounces around until it gets to the other end, and then it goes out, and you can detect it with some kind of instrument, a photodetector. Fiber, compared to wire, is able to transfer enormous amounts of bandwidth, very high data rates, over very long distances. This is because fiber, because of its physical properties, allows very wide ranges of frequencies through. And it also attenuates signals very little because it's very pure. Light just tends to zap right through it. So signals can go for a long way before they're attenuated. There are, just like different kinds of wire, there are different kinds of fiber. The 2 most common varieties are what is called multimode and single mode. Multimode is the cheaper version, so it's good for shorter links, maybe links that are less fast. Single mode is the more pure, higher quality version. In a single mode fiber, light can only go straight down the middle because it's so thin. And single mode fibers can be used to carry signals up to 100 kilometers or so. Just like the wires, there's a lot of construction here. This portion in the middle, this is actually the fiber. The rest is just all the padding and packaging that goes with it, the cladding and the jacket. And then over here, there is a bundle with 3 different fibers in that one cable. And the third kind of media that we'll look at is wireless. Wireless is fundamentally different than wires and fiber optic in one important respect. And that is that the sender is radiating a signal in many directions. It's radiating across a region. So the signal, rather than being confined to a wire or to a fiber optic cable, radiates in many different directions. This has an advantage that it can reach potentially many different receivers at the same time to everyone in the vicinity, but it also causes a sizable complication for using wireless systems. That nearby signals, which have been transmitted on the same frequency, can interfere with one another at the receiver. This picture shows the setup. Here we have a laptop in the middle, so this is the receiver. And you can see that there are two transmitters. I've shown one is a little closer, so there's a fairly strong signal that arrives at this laptop. The other one is further away, but its signal still propagates and reaches the laptop. So this laptop receiver will receive two signals at the same time, two signals superimposed on one another, so it will be somewhat jumbled. Now, because these signals interfere, we need to be careful and coordinate the way the wireless spectrum is used. Guess how we do that? Well, here's one answer. Look at this chart. This is quite amazing. This is the United States frequency allocation chart. I don't expect you to be able to read all of that. The key issue here is that this chart shows how regulation is used to manage the different parts of the spectrum. Different frequencies are used for TV stations, radio stations, police communications, aircraft, as well as computer networking. So the government regulates who's allowed to use what frequency. You can't just use any frequency you like. In fact, just these small circled regions are the ones which are used for Wi-Fi computer networking. There are also some other 3G frequencies, but only very small portions of the spectrum are actually used for data communications. Even within these circles, it's just a small portion. The portions of the spectrum that are used for Wi-Fi are actually fairly interesting in terms of a story. They are the frequencies that we like for data communications tend to be in the microwave band, from hundreds of megahertz up to several gigahertz. Now, that's where you'll find Wi-Fi as well as 3G, cellular network communications. Wi-Fi is actually transmitted in what's called the ISM band. You can see here this figure just shows different frequencies, and frequency goes up to the right, so this is frequency, and some portions of the frequency were reserved as part of these ISM bands. They're shown here. Wi-Fi actually uses portions of these bands. In, I think, 1985, the FCC decided to allow anyone to use these bands without a license. So you don't have to buy an expensive license, as TV stations and mobile network providers or cellular network providers do. That's why these bands became unlicensed. These were actually the junk bands, garbage bands, just left over with a lot of interference and so forth. They were considered undesirable. But in these circles, people began to use them for computer networking. That was part of the intention. Now, this means that, within this area, many different computers may be using the Wi-Fi, so they will all have to coordinate themselves, since the government's not doing it for us by exclusively allocating us a frequency. But these bands have been a major success, as you know, by the prevalence of Wi-Fi today. There's been a huge amount of innovation in different kinds of computer networking technologies using just this tiny niche of the spectrum. We'll learn more in the next lecture about how signals propagate through different kinds of media.